Welcome back, guys. Today's gonna be fun because I had a question come through at the Fireball Tool forum on how I would build this car trailer ramp. It looks kind of unique because we have a lot of little spacings we got to deal with. We have some odd shapes to have to handle. So I'd like to take a little bit of time to show you how I'd CAD it up and build it right here on the Fireball Tool table. So I've had a recommendation on the forum to draw this. This is a car ramp with some angle iron, some channel iron, and the whole bits. I don't quite have all the information here. I would like a side view of this, but I think I could probably work my way through. So I'm drawing this in CAD. This is my part. And as you can see, we have some 2x2 angle iron, some 3-inch angle iron, a 5-inch angle iron, and they're all laid out on 8.5 centers. This is the kind of way I think it should be built, with everything kind of hitting flush across the top. But like I said, I don't have a side view, but this is my personal recommendation how I would build this. So what I'd like to do is start with our table. So I can import the 10254 table is what I want to use. And then I can import and add my little car ramp ladder. Now, what I have done is I've mated this surface here to the top of the table. Now, I'm doing this upside down. So as you can see, the V is facing up. So I could weld inside here and I can rest all these components down on a shim or on the table surface, and since everything on the top is coplanar with each other. So I'm going to build this upside down. And I've also kind of squared it up to the edge of the table so I could kind of see what I'm working with here. Now I know I'm going to have to locate these two pieces and the end. I'm going to kind of call this 0, 0, this left-hand corner over here. So I'm going to start with by bringing in some riser blocks because this is a little tall. So let's browse my library here. There we go. Okay, find my tooth block with riser. So I'm going to just drop it anywhere in my assembly here. An assembly is basically you're taking a whole bunch of parts that are already drawn and you're able to combine them together with what you call mates. So what we want to do with a mate up here is we want to just kind of give it a place to stick. If you kind of think about that, if there was Velcro and you wanted your parts to kind of stick together, how would you want those parts to stick? And I'm giving this a coincident, which means top of the table to the bottom of the block is a coincident mate. I hit OK. So it's still not defined. See, I can float it around here and I can right click my mouse and rotate it. My little ladder here is also floating. I think I'm going to start it off probably here. Okay, give ourselves a first hole. I'm using the riser block here because, as you can see, when we put these together like that, I want to have this angle iron and this block touching somewhere. And it would also be nice to have a couple holes up here just in case I wanted to wrap a clamp around it and grip onto it pretty tight with something. So it gives me a little bit of flexibility. To get this thing squared up, this point and this hole, I'm going to mate with a tangent. Okay, and then the side of this block with this hole, also tangent. Now in SolidWorks, these two pieces are individual, this riser and this tooth block. So in order to copy them, because I'm going to want another one, I'm going to select both of them and I'm holding control at the same time and I'm going to left click it and I'm going to drag it off so those pieces stay together. Okay, I'm just going to drag it off the side here, let go. Now I have both of them stayed together. Okay, so I drag these over here. And we're just going to repeat the step. Select that. I can select this. I'm holding control, hit mate. The further apart these are, the more accurate we are. So we want to space them out really far. And then I'm going to go just like we did before. Hit mate. And then we hit this one and this one. Good. Now that we have those two blocks in order, I'm going to mate this piece to this piece. So I'm going to select an edge, that little edge right there on this. And then this right there, hit mate, and it just jumps forward, and now we are in a line. I mean, as we can slide this back and forth, but I can't push it out. We are touching those two blocks. Now we need to locate this piece right here. We need to lock it in position. So I'm going to use some fence blocks for that. Browse. 1x4 fence block. Yep, okay, as you can see here, it's a really simple block. It's just a 1x2x4 block. Some holes in it. Select the bottom, select the table, mate. And now I want to move this probably right there. So what I want to do is get them in that hole. I'm going to select this hole, hit mate. There we go. And then once again, we want another one. So I'm going to hold control, left click, and then we'll repeat. And just like this, and mate. Okay. Now I like to turn the blocks endo this way
because the block doesn't want to rock. If you turn the block in line with the part, widthwise, there is a little bit of wiggle room in the pins, just for manufacturing purposes, and the table holes get yuckum and dirty in there. The block will rock a little bit. Sometimes that doesn't even matter. I prefer to do the block like a T in line with the parts. And that this also gives us a 1 inch offset. You can see by the holes. I can flip this block around and push it out 1 inch. So I have a little more flexibility there. Okay, there and there, hit mate, and then here and here. I don't know if you guys know this, but in SolidWorks, you see how this does not look like a circle? So what we can do in SolidWorks is we go to options, we go to document properties, and we go to image quality. And this is what the hole looks like, right? So we can crank this up. I'm going to crank it up, not quite into the red. I'm going to hit OK. There. I see now all my holes are holes. So we'll do this for you guys, but normally I just run them, I don't know, octagon, so it doesn't slow the machine down. This one I did not mate, so we're going to click here, hit mate. And now we have a nice good endo. Here, here, and here. Mate. This thing should be locked. Correct. But we don't have a way to lock this tube in line. Technically, this is an individual component, right? This guy right here. It can slide back and forth. So let's give ourselves an endo. And we want overall length to be exactly the same. So we're going to endo this end over here. Okay, whatever happens over here, we can kind of float a little bit because it's like a welded joint per se. Now, what are we at? So in SolidWorks, we can do a measure. We can go to evaluate, hit tape measure, that there to this here, 74.5. Okay, now using any tooth blocks, we're on 1 inch center. So anything halfways, we're gonna have to put a shim in there, or we just use another tooth block. Tooth block looks like this. If we were playing chess, these pieces would be your queen. They do just about everything. They're extremely versatile. So you're gonna want a lot of these. All right, so now if we look down from the top, what hole do we pick? Okay, so this is one thing I like about the Fireball table is our blocks are as wide as our hole spacing. So if I go over to here, we have basically full coverage. I could put 2 blocks side by side and create a wall. Some of the other smaller tables, there's going to be a gap in between the fixtures. So for this instance, I don't think that really matters which one we go into. There to there, and there to there. That looks good. And then you see now we're sliding in the slot. So I'm going to select this surface and this surface. There we go. Now we're locked in place. Now, where do we put this? Well, we'll talk about that when we create our drawings. But as you can see, we are off the center. So this radius should match up with this tangency like this one is, and this would be your 0, 0, but we've extended this block out. Now, these blocks normally have teeth on the bottom that correspond with teeth in the washer, but for modeling sake, we don't include that in here because it's not necessary. It just bogs the whole machine down. We will find out this distance, how far we've moved it later. Basically what we're measuring from is the center of this hole to the center of this slot. This would be 0, 0, this is unknown. So I'm going to drag another one of these over to here because I know we're going to have to do the same on this side. So we're just going to do the same goofy thing we've been doing. Hold control, hit mate, and it's automatically going to mate them together. And then we will do the same thing up here. Mate, hole, mate. Face of this to face of this, locked in. So now this can't go endo, but it can slip this piece right here, right? So we need to block it in. I know we're at 15 inches from outside to outside, which we could use a fence block. But if you look at the fence block, see how it's short, right? And this is a piece of channel iron. We don't want this channel iron to roll. So that's why we're using the tall risers. But technically, we could use a fence block over here and it would land on 1 inch. But we want full control here. So we're just going to keep going with our tooth blocks here. I'm going to select him, and I'm going to select him. There's a lot of talking going on here. Normally, I could just buzz through this. Once you start doing this over and over and over again, you just know exactly what to do, and you can just see it. And it just becomes second nature. I like that. So let's mate him up here, right to this point. Coincident? Yep. It's really kind of magic. We are setting fixtures around an optimal shape. And then when we're done with it, right, you can hide and it just disappeared, and all you're left with is fixtures. And this is reality. This is what we're trying to get to, is where do I put my fixtures so that I can recreate that shape? Because basically this is just an imaginary object right now in the real world. Okay, one more time. And then let's kind of want to rotate them around so they're kind of close to where they need to be. Getting a little funky on me. Mate, you know what's fun about this is I don't care about the measurements. I don't care about anything. I just want these blocks touching this imaginary component. This doesn't matter if this was drawn in metric or whatever weird measurements. I don't care at this point. This is looking pretty good. This is pretty standard stuff, pretty basic, but this is where it starts to get a little tricky. These rungs right here are always tricky because there's just so many of them. The same thing happens with pickets and railings when you're doing that kind of stuff. I think it's worth taking the time to put a little fixture in here. So the space in between here might be too long for this guy. This is where you guys have heard me talk about having small fixtures. Like a 28mm table, they have very long fixtures, which isn't ideal for stuff like we're doing right now. So let's just plop this down in here and see what happens. Do we have enough room for one of these blocks? And as you can see, we don't. That's all fine. So what we're going to go do is insert component. Let's browse. We want a short tooth block. Tooth block, 3-inch long. I'm going to show you 2 different ways to do this. Look, this guy. There he is. Look at that cute little guy right there. So what we have here is a short tooth block. Let's get them blocked down to the table. We're gonna mate this with this and make it tangent. Okay, so as you can see, because of the way this works and where it touches, we're only gonna be able to use 1 bolt. This is frustrating because the block can twist when you only have 1 bolt in the system. But what the Fireball table does have is a grid. So you're able to line the edge up with the grid line in the table. I think this is one option. We're gonna mate this to here, right there. We're gonna mate, there we go. And then that's kind of how I would do that one. The next solution is what we try to do is use some fence blocks and some shims. We just grab him. I like to mate the bottom. We're gonna mate them right there. Okay, because we're on weird spacing, we're just gonna look at what hole gets us as close as possible. So this one, not so good. We're touching there. We're gonna jump them back a hole like that. Mate that one with this one, make this one, make this one. Excellent. Okay, so there's that. And then what we're gonna do is we're gonna measure the distance between this block and this edge when we get to there. I'm gonna just kind of give us a little preview. That edge to this edge is almost 1 inch. I mean, we are 50 thousandths away. We could round it down to the nearest 16th or closest 16th. We'll take a look at that. But I think I'd round it to 1 inch and just call it that. If that was the case, I'd just probably flip this block around and be good. But we'll work on that here in a minute. That's one way, and we'd probably go down here. I guess where I'm going with this is that we would use a shim, the Fireball shims, to shim this block out and touch. That's one way to do it. Let's mate. And we could probably get away with one of these if we wanted to. All right, so that's solution number 2. And the neat thing about this one is you could probably get away with front and back. So you see how we have a block here, and then we also have a distance here and here. So we could shim off the front, shim off the back, and we could locate 2 at a time with 1 block. So the next block over, we could do the same thing like that, or you could just use 1 right here in the center. It won't really give you a squareness, but you could probably get pretty close with a square. And you can also line these up with a grid and the table. You can kind of sight down it. It just depends on how accurate you want. So there's another solution. Just put 1 in the middle, shim off the back, shim off the front, and that gives you your distance. Okay, so now that we've tried a couple different versions of how we can keep these posts in position, we have a couple more problems. First thing, we have the twist. You can see this is on the V. So how can we keep these all aligned? What we could do is just use a piece of bar stock and make it like a 2x2, maybe a 2x2 or a 1x2 or a 2x1. 2x1 or something. Let's extrude this out over here. So you can get a piece of material and lay across the top of these. So that's one way you could do it. Not the most convenient, but it would work, and then you could clamp this down on top with something, okay? The other idea is that we just make our own fixture. That sounds pretty interesting, right? Okay, so let's delete this guy. Because the beauty of a fixture table is there's really no right or wrong way to do it. It's just whatever works best for you. So what I was thinking about this is maybe we make our own custom fixture. And we can do that with CAD and a 3D printer. Okay, so let's try that scenario. Let's cut this model in half here. Because we're already in CAD, this is the sweet way to do this. So what we're trying to do, remember, is we're trying to get an even spacing from here to here. Let's do this, let's make a new part. We're gonna click here. And we're just gonna sketch out a little block. But I think we're gonna start a little high. And I'm gonna make my own block. Sits on the table. I'm gonna go down to this point, and I'm gonna go, oh, let's go up a little higher. There we go. And then we can horizontal. Let's make this a real dimension. Make it 2 inches. Okay. So there we go. Now we got our own little custom spacer block, and then we can jump this block down the line. So let's extrude this out. So let's do it 1 inch. There we go. And let's get back to normal. So something like this would work. And the problem is getting this out. That's kind of why I have this over here, so we can kind of swing it and get it out of there. So you could tack, move this block or print 2 of them, and then jump to the next one and go tack. The problem with a custom fixture like this is you might have what I like to call stacking tolerances. So that may not be the best idea. So let's make one more of these fixture blocks, but let's make it to where we could put a bolt in here, okay? So let's try version number 2. So let's do new part. I'm gonna sketch right there, and then I'm going to cut the model in half so I can see what I'm doing. Hit OK. All right, so now let's make a line. Now there's rules for making fixtures for your table. Is that, remember, the Fireball system uses a 2-inch overall thickness is what's very helpful. So let's just go to here. Maybe this little point that we make right here is important because it gives us maybe a line up. Let's go something like this. I'm just gonna come up like this. And let's make this a hole here. Let's make this 1 inch. I like making things normal numbers. 2. This is probably 1 inch. Just make these 1 inch. Okay, so I can see I could get a 2 slot or a holer in here. Maybe let's make this 3/4. 0.7. We're just messing around. Let's make this 0.75. Give ourselves a little more wiggle room. Extrude boss base, 1 inch. And there we go. So you can kind of see where we're going here. And then maybe what we do is we create a slot on here. I'm not a real big fan of slots. Sometimes they are just what they are. They work. Well, let me give myself a center line here so I can kind of see where I'm going. And then this is the slotting tool. I'm just gonna get a slot going. And we need this to be 3/4, so I like to add 3/1000 of an inch, 0.753 to the slot. Pretty good. If we don't want this to be too big, let's just make this 3 inches. Technically should be 4. I don't really know where it's going because this could be varying as we jump this. See how the slot's going to change. As long as we can get one hole to like hold it down, I think that's really all I'm looking for. And then I'm just going to fully define this sketch. Hit OK. I'm going to extrude cut 1 inch. And there we go. Okay, so I have this kind of funky, weird fixture that we just made. Kind of fun, right? And I'm gonna hit OK. And now let me make it float. Let's rename the part, the open part. There she is. Let's hit save. This is going to be car spacer with slot. I'm gonna save it into my fixture file here. There we go. Something like that. And then we can go insert components, car ramp spacer with slot. Boom. There's my new custom fixture. And what we can do is, I'll show you how it would work. Let's change the color on this guy. And let's change him to blue. And then let's mate bottom with this to bottom of that. And now let's look over the top. We got this wall with this wall. Something like that. This block could flip around. This block, this block. Yep, and then I could put a bolt in there, and then off I go. So this is just a block that's just creating a space, and then this is holding it down. But that's kind of idea, and then we could 3D print that block, which we might just do, and we should go kind of show you how that would work on the shop floor. Yeah, kind of fun, right? So you could do a simple block with a 2x4 or something, now that you know what the block distance is and all that good jazz, to create your own fixture, and then you just save this in your little stockpile. Or the other idea is we create a big fixture, which means we just create a long tube and we put a stop on every single one, and it just kind of locks in. All right, so now what we're able to do is create a map of all of our fixtures, but we're missing one thing. We need the hole ID. We need to label the holes. So I'm going to browse my fixtures here, and on top here I have what we call hole identification right here. And as you can see, what I've laid in here is an actual part. See, these were text and we extruded it out. So what we can do, kind of upside down here, that's okay, is grab this and kind of pull it wherever we want, because we might be adding or subtracting tables, we might be in a weird position. It's just kind of better to label the holes this way that we found, so like that. And as long as we're kind of looking at the top view, we're okay. Because when we go to create our drawing, we're left with this: A1, A2, A3, and so on. But as you can tell, that this is awfully small. So let's click on this and let's use a custom scale. I know from experience I'm probably going to want to be somewhere in the 8 or 7. Let's just see where we're at for 7. I can work with this. We want to make it as big as possible. So what we're looking for, once again, remember, is where are these fixtures at? I need to know where to put them. I know from experience that SolidWorks doesn't like to really give me a hole center, so we're going to give ourselves that. Done this enough times. I'm going to come up here to this little eyeball, select this icon. This is a temporary viewing of the hole axes, and you can see that pops up the hole centers. And then I'm going to come select this little dot up here, and I'm going to give myself these 2 dots. This is just easier for SolidWorks to grab these points when we go to dimension. I can also kind of look at it and make sure I can pinpoint this. And what we're looking for is the first hole at the tooth block that's visible, and the hole center of the slot up front. These ones aren't really that important because these ones are just going to be floating. The whole distance is set by the overall. This one is also, we need a label. See, this is why I like getting close in here to ID what we got. So it's this hole and this hole. But you could see if we were just kind of to grab dimensions, we might get off. Kind of like to come in here and do that. And of course, if we chose this style, we'd have 4 or 5 of them going down the row, and we would need to do that to all of them. And I know I'm giving you a lot of information here, but I'm trying to give you guys as many ideas as possible. So basically, we're just need to map these out. And the way it works, like I said, this is a tooth block. It doesn't have any teeth in it for the model, but what I need to know is how far out extended is it? And oh look, we're 1 inch. So what I want to make sure that our map is in inches, and we're down to the 16th. So you can come over here and select this little icon down the bottom and go to 16ths, and we're going to round to the nearest fraction and hit OK. So because this is 1 inch, like I said, I don't remember how close we were. We could use a fence block here for this application if we wanted to. And typically, because these are in a row, I wouldn't dimension it. I would just know that they're the same. But because I'm on camera, we will do this for good practice. Go up here to this guy. Also 1 inch. Knew that. Going into it. Looks good. This is probably the weird one right here. 1 and 15/16. Okay, so it rounded down. Pretty easy. And then everything else has got its own grid. So we're just going to go put it in its position. I would like to 3D print this real quick. Should probably take an hour on the Bamboo Labs printer. So let's go print this. And by the time I get everything set up, this will be done and we'll just kind of take a look at it. All right, I'll see you down on the shop floor.
Well, we have our little recipe to build this car trailer ramp. So you gotta treat this like we're actually cooking something, okay? So the first thing that I like to do is pull out all my ingredients, which are our fixtures, get them all laid out, make sure I have enough of everything to accomplish this. And then from here, we're just gonna follow the recipe, just like we're baking a cake. It's really that easy. So let's build it. For this demonstration, because we're not doing an entire fixture setup, I've pulled out 6 fence blocks, 6 tooth blocks, a short tooth block. I have, of course, the matching 6 tacking bolts and the 6 swivel pins. If we were going to fixture this all up, we need a little bit more than that, but for this demonstration, this is what I'm using. If this is the first time you're seeing a Fireball fixture table, take a look at this. We have engraved letters A through Z going up the left side and 1 through 50 going up the front. These have all been engraved and machined into the table so they can't come off. That's pretty cool. And this matches our fixture map. And all I have to do is just follow everything that I've already done in CAD. It's literally that easy. Okay, so we're gonna start with fence blocks, and they just drop in the hole. Now remember earlier in this video I told you that they had a little bit of wiggle. What I mean, if you're gonna fixture up against the side, see that little bit of wiggle right there? That might throw you off, it might not. But if we were to turn it this way, you see how it doesn't have any wiggle? So this is why I like building off of the ends, because it's 90-degree angle and the side movement doesn't affect this reference surface right there. So that's why I like to turn them just like that. All right, so all I gotta do is just follow the holes and we'll whiz bang through this really quickly. 12F, JF, 22H. The next thing is the tooth block. This is the first time you're seeing it. This is the chassis we were using in CAD with the 6-inch riser, okay? And then this is the actual tooth washer. And this is what does all the locating. And in this instance, all the tooth blocks land on an 1/8 of an inch increment. So this is the washer I'm going to use, and it's clearly labeled. That way I know I can't mess anything up. It's going to precision locate these blocks. And this is what makes the Fireball tool system so special and why we don't even need a tape measure. So I'm going to put the tooth block where it belongs. I'm going to show you how I do this one time, and then I'm going to fly through it. So what we're going to do is put the washer on C5. That's going to be the first hole. And then I'm going to put my block right on top. Just like that. I'm going to put the pin in the hole. This is the lockdown pin. I like it as far forward as possible. And right there, this block has been zeroed out, and you can see this by the tooth washer is up against that shoulder right there. Like I said before, the further out we're extended matches the scale. So you can see we can still pivot, and that's what this pin does, is it locks the back of the block from pivoting. And we also have grid lines of the table so that we can line it up perfectly and lock it down. No matter how hard I hit this, it can't slide back, it can't slide forward, it can't twist or turn. It is permanently locked there. If I want to remove a part, maybe this is kind of blocking it, all I gotta do is pick it up out of place. And then because I already know what hole I was in before, I drop it back down and it's in the same spot. So it's not a big deal to have to pull fixtures back out of the hole to remove a part and then put them back. It's really that easy. All right, so now I'm just gonna go and motor through this really quickly. 38. 41. So we're all done with the fixture setup for this demonstration, but I want to bring you in close to just show you how dialed everything is. So this table has a scale in it, and you can see we're matched up 1 inch extended. So the teeth does all the locating, and we can visually confirm that it's where it needs to be off the grid line. We have a lot of system checks built into the system that really make sure the block is where it needs to be, and you can identify it if there's something wrong. And another neat thing is you notice our blocks are 2 inches wide, which is really nice. So we have full coverage across the entire table. For this exercise, we're going to be using small sections of material because I don't really want to waste it, build this just for demonstration, but I would like to talk about some of the things we've talked about in CAD here on the floor. And that was like this 3-inch channel and why I used a 6-inch riser. So we chose not to use a fence block because of this material, right? It can still roll. It's not tall enough. So that's why we picked the risers over here, remember? So now when we have the 2 legs of the angle iron bumped into this, look at that. Now this riser controls the roll of the material. So what we can do is we want to pull back into this block because you kind of see how it wants to move away from it. It's really important that this stays square. So we can use a clamp like that and hold it up tight against the fixture. So that's why we chose the tall risers versus the blocks. Okay, on to the next one. Remember we picked a tooth block right here and why we can't use a chassis? Because this 45 goes like that, right? And this tooth block is too low. So we need to add a riser on it, and I'm gonna show you how to do that. So as I pull it off, you can see we have 2 components and they mate together just like this. This is why I like the Fireball system, is we can configure it just about any way we want. Pivots, but now we have these 2 screws that lock it in position and keeps it square. And then we just quickly add them together with the screwdriver and we suck everything up tight, and because they're all machined, everything lines up really good. And we have a nice square part. There's no teeter-totter. It's perfectly 90 because these are all machined components getting bolted together. So now we have a little riser there, and let's put this guy back where he belongs, and I'll show you why we wanted him. These are the things you're gonna learn and things you can see in CAD. There you go, right? Now we can bump him up against this tall riser, and it gives us a nice endo stop. We still have this to control, but remember, we'll work on that in a minute. All right, setup number 2 requires these shims. This is a great assortment of spacer blocks. These are all machined parts. We have 2x2 blocks, 1x2x1, just about any configuration you'd want, all the way down to 1/32 of an inch. Some of these are magnetic, some of them aren't, depending on the thickness, okay? So for this demonstration, it looked something like this. We needed a 1/2-inch spacer, goes on the front, and then another spacer goes on the back. And that way you can have the correct spacing front and back in between. So for the next block, we need something like that. A 3/4, 3/16 would get us what we need for this next operation. We're just gonna treat it as such. It would look like that. And then we do on the other side, 11/16. That's how this setup would look if we just chose to do a 1. Remember how we talked in CAD about keeping these legs correct? This is how we do it before. We get all our parts laid in, then we lay a straight edge across, and this would keep everything nice and 45. All right, once we had all our stringers in here, we could put a rail across there and it would straighten everything out and hold it down. Let's just measure center to center distance. So remember our center to center distance was 8.5. Look where we line up. We're exactly 8.5. So by building off the center block and then spacing each one where they need to go, this is a great way to do it. You might have a little bit of squaring to do back and forth, but depending on how accurate you need to be, maybe it's just an eyeball thing. Now the next setup, remember we talked about doing a 3D print. This print took 1 hour and 10 minutes to make, and it's another solution is to make your own fixtures. And let's set that up to see how it would work. Let's say this one was located. How do we set the next one? We set this guy up here, and we'd have 2 of these guys, and we could plop it down in there just like that. If we wanted to have a whole bunch of them and fixture them down, we could probably do that too. Once we get one built and get it all in there, we could block these down. So after you're gonna get one done and get it all laid out and get them all in there, you could 3D print yourself a whole bunch of these custom little fixtures like this. Something like that. That way we're away from the edge so we could weld in here. And then we can just lift this whole thing out and we'd have 2 of them. So that's the third fixture option when you have some weird stuff like this. This is pretty cool. I like this technique. Hopefully you guys enjoyed this quick little demonstration. And as you can see, there are so many different ways to do this. None of them are wrong. They all have their advantages and disadvantages, but that's just the benefit of the Fireball table system is that you have many options to get your job done and have it repeat. So picture this example. Your customer comes in, orders 10, then comes back in 3 months later and says, hey, I need 20 more. Can you recreate the same thing? You pull this out of your Rolodex, start getting to work, lay it all back out exactly the way you had it, and the customer knows no difference. It tastes exactly the same to him as it did before, and that's pretty cool. So that's the idea of this whole fixture map thing. Hopefully you guys enjoyed it. Please leave more suggestions at the Fireball Tool forum. And if you have more questions, please leave them there too. And until then, I'll see you on the next one.